Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using method of variation of parameters. So let's get going. Problem: solve d square y by dx square plus 16y equals to secant 4x. Solution. So firstly, let's find the order and degree of the given differential equation. So here, firstly, identify the highest derivative. So here d square y by dx square is a highest derivative. So our order will be 2 and degree will be the highest power of the highest derivative, which is 1, right? Now coming to the solution, given differential equation d square y by dx square plus 16y equals to secant 4x, right? Then we can write it in operator form since we know that d by dx equals to capital D. Then you can write this as d square y plus 16y equals to secant 4x. Then take y common from these two terms, you'll get d square plus 16 into y equals to secant 4x, right? Which is in operator form. F of d into y equals to some q, where f of d equals to d square plus 16 and q equals to secant 4x. So we know that method of variation of parameters for an ordinary second order equation or general second order equation y double dash plus p y dash plus qy equals to x, right? So we'll consider RHS part as x, and here x is a function of x. In RHS we also have function of x, so let's consider some x. Okay, let's consider some capital X for our convenience. Okay, fine. Now we need to find the general solution to the given equation, which is given by complementary function plus particular integral, right? So we'll find complementary function, complementary function using the auxiliary equation of homogeneous equation of this non-homogeneous equation, that is from f of d into y equals to 0, we'll get yc, and we'll find yp using this method. Okay, firstly let's find complementary function. So we know that the complementary solution is given by, or complementary function is given by the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is given by f of m equals to 0, where f of m equals to, replace differential operator d by m in f of d, then you'll get f of m equals to m square plus 16. Then our auxiliary equation will be m square plus 16 equals to 0, right? So we can find roots in two ways. Just consider m square plus 14 equals to 0. From this we'll get m square equals to minus 16. Then m equals to plus or minus square root of minus 16. You can split square root of minus 16 as square root of minus 1 into square root of better. You can just write minus 16 as minus 1 into 16, which is equals to plus or minus square root of minus 1 into square root of 16, which is equals to plus or minus, we know that square root of minus 1 is I and square root of 16 is 4, which is equals to plus or minus 4i, right? Or write plus 16 as minus of minus 16, right? Then you'll get, you can write minus as, since we know that I square equals to minus 1, then you can split minus 16 as minus 1 into 16. Then you can write, also we know that 16 is a 4 square. So you can write minus 1 as I square into 16 as 4 square. Finally, you can write minus 16 as 4i whole square, right? So you can replace minus 16 by 4i whole square. Then you'll get, right? Then this of a square minus b square form, which is a plus b into a minus b. Now equate each factor to 0. If you equate first factor to 0, from this you'll get m equals to minus 4i. And if you equate the second factor m minus 4i to 0, you'll get m equals to plus 4i. That is, m equals to minus 4i and plus 4i. Or simply plus or minus 4i. You'll get the same thing, right? From this, we can write the complementary function. Here the roots are complex conjugate. Right? So you'll get complementary function if you have some a plus or minus ib, the complex conjugate root, then solution is given by yc equals to, that is complementary function is given by yc equals to e power ax into c1 cos bx plus c2 sin bx, right? Then our solution will be yc equals to e power, for a you don't have any a here, right? Consider it as some 0 into x into c1 cos, in the place of b you have 4, so write 4x plus c2 sin 4x. So therefore yc equals to e power 0 into x is obviously e power 0, since e power 0 equals to 1, so you'll get 1 here, right? Or you can write one more step for your convenience. From this we'll get y equals to, yc equals to c1 cos 4x plus c2 sin 4x. So we have yc equals to c1 cos 4x plus c2 sin 4x. Now what we have to do, we'll compare yc with the method of variation of parameters. So in this we have yc equals to c1 f1 plus c2 f2, right? Compare with yc equals to c1 f1 plus c2 f2. Then you'll get f1 equals to cos 4x and f2 equals to sin 4x, which are functions of x, right? Then find f1 dash and f2 dash. F1 dash, derivative of cos 4x is minus sin 4x into 4. So we'll get minus 4 sin 4x. Now find f2 dash, which is equals to derivative of sin 4x is 4 cos 4x. Okay, in this we'll find particular integral, which is p f1 plus q f2, where p and q are p equals to minus integral f2x by f1 f2 dash minus f1 dash f2. Here x is nothing but the RHS part, which is a function of x, right? and q equals to integral f1x by f1 f2 dash minus f1 dash f2 into dx. Here also the capital X is nothing but RHS part, which is a function of x. So in both p and q, in the denominator of integrand, we have f1 f2 dash minus f1 dash f2, right? So let's find f1 f2 dash minus f1 dash into f2. Okay, f1 f2 dash minus f1 dash f2, which is equals to, what is f1? f1 is cos 4x into f2 dash plus 4 cos 4x minus f1 dash minus 4 sin 4x into f2 sin 4x, which is equals to 4 cos 4x into cos 4x is cos square 4x minus into minus plus 4 sin 4x into sin 4x is sin square 4x. If you notice, we are having 4 in both the terms. So let's take 4 common from these two terms and you'll get 4 times cos square 4x plus sin square 4x. Otherwise, you can just write this as 4 times sin square 4x plus cos square 4x. We know that a sin square theta plus cos square theta equals to 1. Since sin square theta plus cos square theta equals to 1, then the value of sin square 4x plus cos square 4x is 1. You'll get 4 into 1 equals to 4, right? So therefore f1 f2 dash minus f1 dash f2 equals to 4. Now we'll find particular integral. In order to find particular integral, we need to find p and q. Let's find p firstly. We have p equals to minus integral f2x by f1 f2 dash minus f1 dash f2 into dx, which is equals to minus integral f2. We have f2 equals to sine 4x into capital X, the RHS part, secant 4x by value of f1 f2 dash minus f1 dash f2. We already have this value, right? 4 into dx. So now let's take the constant 1 by 4 outside the integral. You'll get minus 1 by 4 integral sine 4x into, since we know that secant theta equals to reciprocal of cos theta, then you can write secant 4x as 1 by cos 4x into dx, right? Which is equals to minus 1 by 4 into integral sine 4x by cos 4x into dx, which is equals to minus 1 by 4 into integral tan 4x dx. We know that since integral tan ax dx equals to minus 1 by a log mod cos ax, then you can write this as, or you'll get integral tan 4x dx is minus 1 by a, for a equals to 4 into log mod cos 4x, right? Which is equals to minus into minus plus 1 by 4 4s are 16 log mod cos 4x. Now we got the value of p, right? Therefore p equals to (1 by 16 log mod cos 4x). Now we need to find q. q equals to integral f1 x by f1 f2 dash minus f1 dash f2 into dx is equals to integral. For f1, you have f1 equals to cos 4x into x, where x is secant 4x by value of f1 f2 dash minus f1 dash f2, which is 4, into dx. Let's write 1 by 4 constant outside the integral. You get 1 by 4 into cos 4x. Since we know that secant theta equals to 1 by cos theta, then you can write secant 4x as reciprocal of cos 4x into dx, right? Which is equals to 1 by 4 into, you'll get 1 into dx, which is dx equals to 1 by 4 into x, that is x by 4. You got q equals to x by 4. Now we can write particular integral. Pi equals to p f1 plus q f2, where p equals to 1 by 16 log mod cos 4x into f1 cos 4x plus q x by 4 into f2 sin 4x, right? This is equals to 1 by 16 cos 4x log mod cos 4x plus x by 4 sin 4x. We can take 1 by 4 common from these two terms. Okay. Firstly, let's split 16 as 4 into 4 cos 4x log mod cos 4x plus x by 4 sin 4x. Now let's take 1 by 4 common from the two terms. You'll get 1 by 4 times cos 4x log mod cos 4x by 4 plus x sin 4x. See, 1 by 4 into cos 4x log mod cos 4x by 4 is 1 by 16 cos 4x log mod 4x plus 1 by 4 into x sin 4x is x by 4 sin 4x, right? So therefore yp equals to 1 by 4 into x sin 4x plus cos 4x log mod cos 4x by 4 . Now we can write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, for yc you have c1 cos 4x plus c2 sin 4x plus yp 1 by 4 into x sin 4x plus cos 4x log mod cos 4x by 4, right? Therefore y equals to c1 cos 4x plus c2 sin 4x plus 1 by 4 into x sin 4x plus cos 4x into log mod cos 4x by 4. So we have seen a problem from differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.